By the end of this video, you will know the basics of how to containerize a Node.js application, how to use a private Docker image repository, use a message broker, specifically Google PubSub, create and manage service accounts in Google Cloud, and how a basic microservices application works in comparison to a monolithic application. Let's get started. When you have a backend service that works as the heart and soul of your business, you want it to be as secure, resilient, and reliable as possible. So hopefully by the end of the day, you will be able to go home and enjoy some quality time with your dog or cat, because the truth is, we go to work so they can have good lives. Now, consider a fictitious company called Pet Theory, which is a veterinarian company that outsources lab tests of their puppies and kitties to third-party companies. Those third parties usually upload the results of the blood test or whatever to an endpoint exposed by Pet Theory's web services, and then those lab results get sent out to the pet owner. Switching over to the code, we could go ahead with the traditional approach and write an API that exposes something like an endpoint that takes in the lab result and then forwards that payload to a bunch of other services. But what would happen if a new research team comes up and they require access to the lab tests? Or what if you want to build something like a clinical history for each pet? You would end up with an endpoint with a considerable amount of logic, or at least one with several function calls. And when you want to integrate a new service or provide extra functionality, you would have to go ahead and edit the code each time, which is prone to errors. We can split up this application into microservices with the following approach. There will be one microservice that takes in the messages from the lab. Then, each team within Pet Theory will have a separate microservice that listens for messages. Finally, a message broker will fill in the gaps between the incoming messages and all the listener applications. Now, every part of the application can work independently. And the failure domain, which is how many services could be taken down in the case of an outage, will be contained to only one application. Another benefit is that depending on the services that we end up choosing from Google Cloud, AWS, or Microsoft Azure, this simple architecture could be scaled out to reach a global footprint. Now, I will show you how to run these microservices as containers and have them communicate through Google's PubSub service, a message broker. Oh, and of course, if you want to see more videos like this from any of the other cloud providers, make sure to subscribe and hit the bell icon to be notified when I upload future videos. Also, let me know in the comments down below what kind of technologies you want to learn more about. Okay, so here I am in console.cloud.google.com, and if you want to try this out, make sure that you have activated the Cloud Build and the Cloud Run APIs. Just type in the name of the API in the search bar and then click Enable. If you see Manage, that means that the API has already been activated in your project. Okay, now in the Google Cloud Platform or GCP's main page, I will type in PubSub in the search bar, which takes me to the PubSub product page. And there I will create a new PubSub topic called new-lab-report, which is the building block of this application. For the microservices, I will initialize an npm project in my local machine and install Express and PubSub's client library. Then I will write a basic Node.js and Express application that exposes a post endpoint. The incoming requests will contain the message that we then submit to PubSub. And that's all that this microservice is going to do. Reduced complexity reduces the chances for failure. Now we need to somehow deploy this code to Google Cloud. I'm going to use a serverless container service, but feel free to use any other kind of service you want, such as platform as a service, functions as a service, and even full-blown VMs. Cloud Run, which is Google's serverless container service, expects a container image. So for that, I will provide a Docker file like this. It basically starts from an Alpine version of Node.js, then declares our working directory, installs the dependencies, then it copies over all the source code for this application and starts the server with the npm start command. We're going to be using this Docker file for the other microservices, so you don't have to hear me walk you through this code again. Once that's ready, we can actually start deploying stuff to Google Cloud. So run this command in the root folder of your project, just replace project_ID with the project ID of your Google Cloud project, which is in the Google Cloud main page. So what's going on here is that we're sending the source code along with the Docker file, so the container image will be built in the cloud. When that command has finished, you can go to the Google Cloud main page and type in container registry in the search bar, and there you will see the container image that we've just built. I will select Lab Service Report and head over to the right, click on the 3-dot icon, and there you will see a bunch of services that you can deploy your container image to. I will select Cloud Run, which will bring me to this form that will help me build a Cloud Run service. The location and name of the service have already been filled in automatically, so I will click Next. There, the container image has already been filled in as well. I will go ahead and click in Advanced Settings and reduce the maximum amount of instances down to 1 from 100 because we don't need that many instances, we're just learning. And finally, we're going to allow unauthenticated invocations for this API, which means that the application is going to be publicly exposed. Non-GCP users or people without a Google account are going to be able to reach the API, so you're supposed to write application level authentication. I will click Create, and Cloud Run is going to go ahead and deploy the container, and after a few minutes it's going to return an URL for this API. Now we can go ahead and send a post request using either Postman or REST client for VS Code. I'm going to use Postman since it is what most people seem to be familiar with. So having set the request type to post and pasted in the URL for the API, I will hit send and wait a couple of seconds. Okay, don't worry. I know what's going on here. This was intentional actually. If we look back at the architecture diagram, you will see the Lab Report API is going to be communicating with the PubSub topic. That needs to be authenticated. PubSub is not receiving messages from random people on the internet. The type of authentication that we're talking about comes in the form of a JSON file. A JSON file for a service account. Think of a service account as a way to provide identity to your applications and users. If you want to know more about service accounts and other forms of authentication in Google Cloud, let me know in the comments down below. So fixing this is going to be quick. In the Google Cloud Console, head over to the navigation menu on the left, head over to IAM and Admin and click Service Account. Then click Create Service Account and give it a proper name. This service account will only be allowed to publish to PubSub, so I'm going to call it PubSub Publisher. Click Create and let's give this service account a role. A role is just a set of permissions. Scroll down until you see the permissions related to PubSub and select PubSub Publisher. Click Done. Then you will see a list of service accounts in your project. Select the one you just created and scroll down until you see the Add Key button. Select Create New Key and create a new JSON key. Download the service account key and please put it in the source directory of your Node.js application. And the name is very important. Please call it key.json. Now just rebuild the container image by running that long command again. And when that has completed, let's go back to Google Cloud. This time we don't need to go to the container registry, so let's go directly to Cloud Run. There, we just need to trigger another deployment that uses the last version of our container image. You don't have to change anything. Just scroll down and click deploy. The latest version of the container image will be used for the deployment. The new revision will be deployed to the same URL, and if we send a post request, we shouldn't get any errors back. Instead, we should get a 204 response code, which means everything went okay. I know this might look like it's taking too long, but the rest of the process is fairly quick, so please stick around. The email service is going to be another containerized Node.js application. Having initialized an npm project, I'm going to install Express, and I'm going to initialize an index.js file with a simple API that takes in the messages from PubSub and logs them to the console. My apologies, but we're not going to be sending any emails today. We're only going to be focusing on the cloud part of this. Now, if you have a closer look, you will notice that there's no key.json file because the email service doesn't have to authenticate to PubSub. That's going to be the other way around actually. I'm also going to copy the Docker file and .gcloudignore file over from the Lab Report service. All there is to do now is build the container image in Google Cloud and deploy to Cloud Run. So again, the way that it looks is start the build jobs with the gcloud builds submit command. Go to Google Container Registry, find your container image by its name. In this case will be email-service. Go to the latest build. In the menu that pops up in the three-dot icon on the right, select Deploy to Cloud Run. Configure the service deployment as before, the only difference being that in step number 3, you will want to select Require Authentication. And yes, we could have this service also open to the internet and don't have to worry about security, but since it's going to take messages only from PubSub, it makes more sense to isolate it and have PubSub authenticate to it. So I'm going to create a brand new service account, this time from the command line, and its name is going to be PubSub Cloud Run Invoker. And I'm going to add a brand new policy binding, which is just a fancy name for assigning a role to a service account or user. In this particular case, being able to invoke the email service. With that, the only thing remaining will be to tell PubSub to use the Cloud Run Invoker service account in order to pass messages along to the email service. So head over to the triggers tab in the email service deployment and click Add Trigger. Give it the name you want and select Cloud PubSub topic as the trigger event. Select New-Lab-Report as the topic to listen to in order to trigger events. And finally, select the PubSub Cloud Run Invoker service account as the service account to be used during invocations. Click Save. After a few seconds, the trigger will be ready to use, so let's try it out. I will open Postman as well as the logs for the email service, and I'm going to send a message to the lab report service. It should make its way all the way through PubSub and be logged to the console by the email service. So as you can see, our application worked perfectly. Keep in mind that even though the message doesn't get delivered instantaneously to the email service, it's also very unlikely that this message will get lost along the way. As a bonus track, and just because you watch all the way through the end of the video, I'm deploying another application that will fail on every message, just a modified version of the email service. This is just to show you that even if one microservice fails processing one message that comes from PubSub, all other microservices should still work without problems. So what you're looking at here is that I send a message to the lab report service. The message gets to PubSub, which then gets copied to the failed customer support service, as well as to the email service, which is still working as intended. Thank you so much for watching. I really hope you learned something today. More videos like this are coming. If you like this video, like and subscribe. Share it with your friends and let me know what you think about this video in the comments down below. Check out this playlist in which I made Google Cloud read a book written by Google Cloud engineers. No, I'm not talking to you. Okay, see you later, bye.
Opening web page.